Hello and welcome to the next exciting part of our adventure with lines. We're going to be talking about how lines intersect today. We know that lines can be graphed, and when you have more than one line that's graphed, unless they're parallel, they're going to meet somewhere. How do we find where they meet? Well, we've done that before. We can find where they meet by solving the equations simultaneously. In the past, there were three ways that we've actually done that. We've either drawn the graph and found where they met, or we've used the substitution or elimination methods. So, one more term that we need to be aware of, and that is concurrent lines. When you've got a whole lot of lines that all meet at one point, those lines are called concurrent because they all meet at a common point. If you have to show some lines are concurrent, the first thing you need to do is look at two of the lines, any two, it doesn't matter which two, and solve those two simultaneously to find where those two meet, the point of intersection. After that, you take the third line, or the third and fourth and fifth line, depends how many lines there are, and you substitute your point of intersection into those lines to show that that point lies on those lines. That would make all of the lines concurrent. Let's have a quick look at some examples. Now, here's our first example. We've got to find the point of intersection between two lines, so this goes back to solving equations simultaneously. Now, if I was going to write this question down and solve it simultaneously, I think I would choose to use the elimination method for this one because it's already in general form. So let's see how we go. We get 3x, now we're going to get 3x minus 4y plus 12 equals 0. That's my first equation. The second equation is 5x plus 2y plus 26 equals 0. Now I can't eliminate those in the form that they're currently in because I don't have the same number, the same coefficient in front of either the x's or the y's. So what I'm going to choose to do is look at the second equation and multiply it by 2. And there's a reason for multiplying the second equation by 2, and that is if I multiply the 2y by 2, I'll get a 4y, then both equations will have 4y's in them. I'll be able to eliminate the y's. So let's have a look at what we've got now. I'm going to rewrite my two equations. I've got 3x, take 4y plus 12 equals 0. But my second equation now becomes, well, everything is multiplied by 2, so it becomes 10x plus 4y plus 52 equals 0. Everything was doubled. So what I'm going to do now is I'm going to make a decision. Do I add or do I subtract? Now the y terms, minus 4y and a plus 4y, they are different. When they're the same, I subtract. So if they're different, I'm going to add the equations. So let's just fix that up. Can't obviously write too close to the edge there. I'm going to add the equations. Now, adding the x terms, 3x plus 10x is 13x. Add the y terms, minus 4y added to 4y, it drops out, it gives you 0y. The numbers, 12 plus 52 is 64, and 0 plus 0 is 0. So now I just tidy that up by minusing 64 to both sides. Divide both sides by 13. Now how many times does 64 go into 13? Well, 64 doesn't look like it's going to go into 13 too nicely. So 64 divided by 13 we'll just write as 64 over 13. If I wanted to, I could convert that to a fraction or mixed fraction. I could write it's minus 4 and 12 thirteenths, which means this is one seriously messy question. That's the x value of the point of intersection. Now I need to find the y value. How do I find the y value? I substitute x equals minus 64 over 13 into, and which one looks like it's going to be the easiest one to deal with? Probably doesn't make much difference at all. I'll go for the first one. 3x minus 4y plus 12 equals 0. So it now becomes 3, in place of x, I put the minus 64 over 13 minus 4y plus 12 equals 0. Now I need to figure out what 3 times 64 over 13 is, or 64 over minus 13. And if I put that into a calculator, I get minus 192 over 13 minus 4y plus 12 equals 0. Let's add the number parts together. The minus 192 over 13 has to be added to 12, and that will give me minus 36 over 13. Minus 4y equals 0. Move the 4y over to the other side. If I divide both sides by 4, that will give me my answer for y, and I will get y equals minus 9 over 13. So when I look at this question now, I've got my two answers, the x answer and the y answer, which is the x and the y value of the point of intersection. So these two lines meet at the point minus 4 and 12 thirteenths, comma, minus 9 thirteenths, which is certainly not something that you could graph easily. Right, let's look at example number 2. We need to show that the three lines are concurrent. So what I think I'll do is I'll take the first and the third line, because both of those lines start with a 2x. It makes it easier to use the elimination method. So let me write the lines down. And then I'll try solving using the elimination method. Now if I'm solving using the elimination method, the x's have the same values. When they're the same, we subtract. So now I can solve this question by going 2x minus 2x drops out, minus y minus minus 5y is minus y plus 5y, which gives me 4y. 1 minus 21 gives me minus 20. 0 minus 0 gives me 0. Following that through by adding 20 to both sides and dividing both sides by 4, I get y equals 5. Let's sub y equals 5 into, doesn't really matter which equation, I'll choose the first one. So it becomes 2x minus 5 plus 1, 2x minus 4 equals 0, 2x will equal 4, divide by 2 to both sides and you get x equals 2, which means that these two lines that I chose will meet at 2, 5. Now obviously I need to consider our third line now, the one that I didn't use, and when I look at the third line I need to find out whether or not the point 2, 5 lies on that third line. So sub 2, 5. So I'm actually substituting in a point into x plus 3y minus 17 equals 0. So everywhere I see the letter x, I'm actually going to be putting in 2. Everywhere I see the letter y, I'll put in 5. Let's see what happens. X now becomes 2 plus 3 times 5 minus 17 equals 0. That becomes 2 plus 15 minus 17 equals 0. 2 plus 15 is 17. 17 takes 17, I get 0 equals 0. That is true. And if you get an answer that's true, that means that the line that you dealt with, in this case x plus 3y minus 17 equals 0, does lie on the point 2, 5. You could finish off by saying the lines are concurrent. All three lines pass through the point 2, 5. Let's try going on to our next example, example 3. Find the equation of a line through -1, 2 that passes through the intersection of those two lines. Well, I need to find where the two lines intersect. So to find where the two lines intersect, I'll need to solve simultaneously. Now I can see straight away, I'm actually going to cheat a little bit, I can see straight away that the second line starts with an x. So I'm actually going to take that equation and times it by 2 and write both of the two lines down now. So the first line was 2x plus y take 5 equals 0. The second line, when I multiply everything by 2, becomes 2x minus 6y plus 2 equals 0. Now I need to solve this simultaneously. I need to look in front of the x's. Both x's are the same, and when they are the same, you subtract. So let's actually subtract and see what happens. 2x take 2x drops out. A plus 1y minus a minus 6y is y plus 6y, which gives 7y. Minus 5 minus 2 gives minus 7. 0 take 0 gives 0. So we end up with 7y equals 7, which gives y equals 1. If I sub y equals 1 into, now I want the easiest one, which will be the original equation before I times it by 2, because it's got the smallest numbers, so I'll use that one. So I get x minus 3 times the y, which is 1, so minus 3 times 1 is minus 3. Minus 3 plus 1 gives minus 2, add that to the other side, and I get x equals 2. So I now know that those two lines meet at the point 2, 1. That hasn't answered the question though, because the question said find the equation of a line through -1, 2 that also passes through 2, 1. So now I can use my fancy equation that I learnt last class, which is this one. Y minus y1 equals y2 take y1 over x2 take x1, x minus x1. Y minus the y value of 0.1, which is 2, equals y value of 0.2 minus the y value of 0.1 over the x value of 0.2 minus the x value of 0.1, which is a minus 1, so that will change that. X minus minus 1. So I get y take 2 equals minus a third x plus 1. Now, because I have this 3 here, what I'm going to do is I'm going to actually multiply both sides by 3. And that will leave me with 3y take 6 equals minus 1 multiplied by x plus 1, because on the right hand side of the equal sign, if I multiply that side by 3, it will cancel with the 3 in the denominator. Leaves me with 3y take 6 equals minus x minus 1. Rearranging it so it's in a general form, I'll plus x to both sides and I'll end up with x plus 3y. I'm also going to plus 1 to both sides, and that is the equation of the line that passes through -1, 2 and through the intersection of our two lines. Let's try our questions now. Have fun.